I didn't see you there. Hello, I'm Natalia.
Hi, I'm Abel.
Hi, I'm Christian.
Hi, I'm Max, and today I'll be explaining the history of our trebuchet.
And I'll be explaining of how the trebuchet, also known as the penny dropper, works.
And I'll be explaining how the physics apply to the penny dropper's motion.
And I'll be talking about the mathematics behind the trebuchet.
The history of the trebuchet all began a long time ago. The trebuchet was believed to be invented by China in 300 BC. It was thought to have been developed from a staff or sling. The trebuchet reached Europe in 500 AD. The word trebuchet came from the French language. The trebuchet application was for war. It was the first mechanical weapon capable of throwing large objects at a large distance. In medieval ages, the trebuchet was built at a larger size. This larger size is given the capability of throwing large objects, such as flaming stones, into castle walls, killing the enemy by the thousands. It was truly a weapon of mass destruction. Every large empire would use the trebuchet when going into war.
Now I will be explaining how the trebuchet works. First off, the base of our trebuchet is 2 feet long or 1.5 feet wide. The sides is what holds the axle. The axle holds the arm. And the penny dropping stick is what holds the counterweight. And as my friend here, once he pulls the tool on, the counterweight will drop and the arm here will swing, which will make the object go forward. Trial 1. Woo! Trial 2. Smashing! Trial 3. The nail here determines when the object is released. So if the angle is on the right side, it will release the object earlier and will make the object go high up. But if the angle is on the left side, then it will make the object go down. When the nail is at a perfect angle, it will make the object go forward.
No.
Today, we'll be talking about the mathematics behind the trebuchet, also known as projectile motion. There are 6 steps of projectile motion. The first step is finding V in the horizontal direction, also known as Vx. To find Vx, use a simple equation. X is equal to V0 times time plus 1/2 of acceleration squared. Our distance here is 10 meters, is equal to velocity initial times our time of 1 second is added to 1/2 of our acceleration, which is 0 times time squared. The 0 cancels out the time squared and the 1/2, making this our only problem. Divide the 1 to both sides and you get 10 meters per second. Of the projectile motion is finding the time at the highest point of the projectile. The equation for that is simply time times 1/2. So our time here is 1 second times 1/2, which gives us 0.5 seconds. Step 3 in finding the projectile motion is finding velocity in the y direction, also known as Vy. To find Vy, use a simple equation. Velocity initial equals velocity final plus acceleration times time. Our initial velocity starts at the bottom, so it's 0. It's equal to our Vy, which we're trying to find, plus the acceleration of gravity, which is negative 10 meters per second. The time is the time at the highest point, so it is 0.5. Apply negative 10 times 0.5 will get you negative 5 minus your Vy is equal to 0. Then you add 5 to both sides of your equation. It gets you 5 is equal to Vy. Step 4 of finding our projectile motion is finding the velocity at the angle of the projectile. So, use the equation a squared plus b squared equals c squared. A squared is simply vx, which is 10 squared, plus vy, which is 5 squared, which is equal to what we're trying to find, c squared. 10 squared equals 100 plus 5 squared, which equals 25. It's equal to our c squared. That equals 125 equal to our c squared. To get rid of the square root both sides of our equation to get rid of the squared. 125 squared gets you 11.2 meters per second. 5 of projectile motion is finding the angle. To find the angle, use the equation tangent inverse times tangent angle equals to opposite over adjacent. The tangent inverse times the tangent angle is equal to 10 over 5. You multiply tangent by tangent inverse by both sides. And then tangent inverse cancels with tangent, leaving you with angle equals tangent inverse times 10 over 5. So the angle will equal 63 degrees. Step 6 of our projectile motion is finding the maximum height. To find the maximum height, use the equation x equals v0 times time plus 1/2 times acceleration times time squared. Our x is our unknown, our velocity initial is 10, our time is 1 second plus 1/2 of our acceleration, -10, times our time of 1 squared. Our time squared is 1 times -10 is 10 times 1/2 is -5 minus our 10 is equal to x. 10 minus 5 is, of course, 5. X is equal to 5. You can see we filled in all equations. We found our Vx, which is 10 meters per second, our Vy, which is 5 meters per second, our V at the angle, which is 11.2 meters per second, our angle, which is 63 degrees, our distance, which is 10 meters, our time, which is 1 second, our maximum height, which is 5 meters, and our time at the highest point, which is 0.5 seconds.
Teach you how to apply physics to this trebuchet. The potential energy right here will transfer into kinetic energy right here, letting it throw the ball the greater distance. The greater the weight right here, the greater the potential energy will be transferred into kinetic energy, thus making the projectile fly further and faster.